In this video, we talk about MOSFET. MOSFETs are one of the most commonly used components, along with IGBTs in SMPS and power delivery systems. They have a structure similar to transistors. A MOSFET has gate, drain, and source pins. When power is applied to gate pin, current flows from the drain to the source. In the circuit, it acts like a type of switch, but it is simply supplying power to the MOSFET gate pin enough. Before we look at the datasheet, let's represent the voltages of the gate, drain, and source. In the datasheet, you will see this sentence. These are expressed as drain source voltage and gate source voltage. First, let's look at drain source voltage. It means the voltage difference between the drain and the source. The greater this voltage difference, the more heat is generated in proportion to the flowing current. Next is gate source voltage. It means the voltage difference between the gate and the source. There is a minimum voltage required to turn the MOSFET on, acting as a switch. This is called threshold voltage. Gate source voltage must be greater than or equal to threshold voltage. For example, let's say we have a MOSFET where threshold voltage is 3 volt. We connect 5 voltage to the gate, 5 voltage to the drain, and an LED to the source. Will the LED turn on? The answer is it will not operate. Why does it turn on dimly when we input 5 voltage to both the drain and the gate? The answer is because the threshold voltage is 3 volt. Gate source voltage needs to be at least 3 volt, but because the gate input is 5 volt, only 3 volt is outputted. The missing 2 volt was taken from the main current. Also, because drain source voltage is 2 volt, the heat in the circuit increases. It is acting more like a resistor. This method is called the source follower configuration. To get a full 5 voltage output, the gate would need a minimum voltage of 8 volt. What is the solution to prevent this phenomenon? We have the same MOSFET and LED. We connect 5 volt to the positive side of LED, the negative side of the LED to the drain, ground to the source, and apply 5 voltage to the gate. This time, the LED works normally. Why does it work just by changing the connection method? It's because the source is connected to ground. In this case, no matter what voltage is applied to the gate, the source is always 0 volt. Therefore, for gate source voltage, we only need to worry about the gate voltage. In this configuration, it acts purely as a switch. By making the source voltage 0 volt, it operates correctly. This method is called the low side switch configuration. In real-world circuits, the low side configuration is used more often. In this video, we learned about the operating principle of the MOSFET and its application in circuits. If you found the video useful, please subscribe and the like button. Thank you for watching.